Good morning, everyone, and welcome to the 2021 Huawei Italy University Challenge. First of all, before to start, I would like to get in touch with you because at the moment we are 44 on this platform. So just say a quick hello on the chat on your left side, just to let me know that you're here, that you hear me, and that you see me, of course. Okay, I can see you. Perfect. Perfect. Okay, it was just a technical check. So, welcome everyone. Let me share my opening slides. Just a second. Here we are. I'm sorry. So, this is an official welcome for you. I'm Lucrezia Argentino, Innovation and Communication Expert of Trio Pinno Italy. And today I'm going to moderate this session, this final event for this year edition of the Huawei Italy University Challenge. I would like to start with a welcome on this platform, at this environment we are in today. You will see it more later, but this is Remo. Remo is basically a virtual online platform that replicates a real life event. Unfortunately, also for this year, this final event is online. We hope that the next years we can meet, of course, with the live events. But I can assure you that this environment will surprise you because let us get in touch like we are live. So you will discover it more later. At the moment, we are, of course, in the plenary session because we're going to listen for the final pitches today of the finalists. But later you will have the chance to explore this environment and jump table to table and floor to floor. So you will see it later. Let's start with the story of the project. Today we are in the final event, but this project started actually last July with the launch of the event. We had the three upskill labs, so labs about soft skills that are important for companies, but most of all, two technical workshops held from the technical people of Huawei, professors, and technician that helped our participants, our applicants, to arrive to their last project, to the projects they updated. So about that, of course, you all know that. But today we are going to listen of projects about 6 different topics that were the challenge of this year project. We had antennas, power supply technologies and systems, analog design and integrated circuits, model-based development, embedded AI solutions, and we also had an open topic for all the innovative solutions that were outside the main 5 topics. Of course, we had a lot of applications, as you know, more than 77 participants in total from 21 universities from all Italy. And in the 30 presented projects that arrived to the last phase of the project, we had to choose. Of course, there's a story about that because in the first place we were going to decide to choose 10 finalists. But the mentors, the judges, and Huawei people in the end decided to choose 11 finalists because there were too much content, interesting content in this project. So we had to change some rules about the finalists. Okay, before to start with the agenda of the day, I have to thank some people. I have a lot of names to thank, but it's important for us because they were the main characters, let's say, of this project, of course, the participants, but most of all the mentors and the judges that helped us to reach our final goal today, to have this event and to create a real community of PhDs all above Italy. So I'm going to read these names. I'm sorry, but it's really important for us to thank you. So Ivan Russo, Silvio Bacci, Roberto Flamini, Vladi Lexer, Dror Mizraci, Luca Romanò, Claudio Scordino, Jimmy Huang, Maurizio Mattili, Jonathan Gambini, and Bai Xinhao. All the people from the Huawei research centers that helped us in the technical workshops and the evaluation of also of the project. Last but not least, also a special thanks to Professor Marco Di Natale and Professor Alberto Liscidini that also held a speech in our technical workshops. So let's start with the agenda of the day. After this short presentation, we will have on stage Renato Lombardi, President of Italy Research Centers, that will welcome you and wish you luck for the pitch session that will be the next step. So we will have the first speeches from after the welcome speech. Then we will have a short virtual coffee break just to let the jury rest a bit. And of course, we will come back after a few minutes to start with the second track of the pitch session. After this pitch session, there will be, of course, the final jury meeting. The jury will meet in remote to decide the finalists, and after that, of course, there will be the award ceremony. As you know, of course, you're here, so you know that, but there will be prizes. So the jury will decide for the first, the second, and the third place. But also, very important, there will be a special prize, as you know, the best innovative project that will reward the lucky winner with the grant of 1,500 euros. So it's not only about, of course, showing your project, but there's also a real competition behind that. So before to start, I would like to welcome on stage Renato Lombardi. I can check if from the direction they can welcome you on stage. Good morning, Renato.
Good morning. Good morning to everyone. Thank you, Lucrezia.
The stage is yours.
Okay, let me start sharing my screen. Hope you can see it properly. Okay. Okay, perfect. Good morning. Welcome to everyone. Thank you, Lucrezia. Thank you, Margherita, Alessandra, for the organization of the University Challenge. I introduced the University Challenge 5 months ago in July, starting with these slides that was depicting for the next 5 years what would have been moving from current deployment of 5G to the next steps by introducing other 3 important corners of for the wireless access, so for the 5G, so from the so-called uplink-centric broadband communication to enable a lot of new type of services, the real-time broadband communication, and then finally in the bottom part of this hexagon, the harmonized communication and sensing. But this is not enough. So if we look at what is coming in the next 10 years, and this is the horizon that we have to take into account in the research, in what we and you are doing. So what is expecting us in the future, or actually what we should do in order to shape the future from here to 2030. And in Huawei, in our company, we found some very important trends that are very much related to the topics of this University Challenge. So first of all is that the 5G deployment is definitely accelerating, and this is going to change again our lives, industries. Already now in many parts of Italy, if you have the opportunity to test the velocity, the speed of 5G, you will see that you can have download peaks up to 500, 600 megabits on your user equipment. But this is not enough. So we need much more for enabling all the services that we have in mind. And particular when we go to the so-called metaverse, so the physical digital integration with very high speed, ultra high density videos, professional virtual reality, professional augmented reality, hologram communication, in which we can transmit all our senses, not only the vision and what we can hear. So in order to have a full interaction. As well, we need to give three dimensions to our network. Current network, mobile network, is predominantly two dimensions, so on terrestrial, but we need also to cover the third dimension, so to give a vertical dimension to our network with collaboration for this 3D coverage between satellite and ground, not only to cover all possible remote corners of the world, but also to use satellite connections for the very, very high speed, that could be airplanes, very high speed trains, and all the maritime traffic. As well, a very important topic that is part of our research, and something that we have very recently started, is how to integrate sensing and communication. So to integrate sensing capabilities into the base stations, into the mobile infrastructure. And these will be very, very important in order to enable the various steps of the autonomous driving, so that the cooperation between the network and the cars, when they will be more and more autonomous in driving, will permit to solve many of the most complicated topics and issues that we can find with autonomous driving, especially in cities, urban environment, and overall to give the autonomous driving the highest possible safety and possibility to exploit the infrastructure. Not to speak of drone management, medical imaging, in a way to really this digital replica to become quasi real. For doing this, and we are of course in Milano with most of the people in our team working on wireless from several different aspects. So if we want to enable this, we need spectrum. So we need also to find innovative ways how to use more efficiently, more effectively the various spectrum bands that we have available, and how to make them be reconstructed with multi-carrier, multi-band, and combine them in a collaborative way in order to reach the capacity and the coverage that we need. I think you are familiar with what happened with the spectrum auctions that we had for 3G, 4G, 5G. Now there will be discussion for using 5G at millimeter wave, so at 26 gigahertz. This will also be part of the PNRR, so the Piano Nazionale per la Resilienza Recovery. So it's very important to find solutions, innovations on how not only to go to higher and higher frequency, but also how to redefine how to use the spectrum and maximize efficiency. As well, and this is also a very important topic of our university challenge, but not only, of course, is how we can have, in order to use the spectrum, how we can use the most efficient way the technologies to have very powerful, very effective antennas, not only to deliver the services, the capacity that we need, but also to provide the proper coverage. And we are moving from the large arrays and aggregate spectrum that can range from 2 gigahertz up to 100 gigahertz. So we need very innovative concepts in order to do that. But moreover, we'll go on distributing electromagnetic intelligence in the environment. There's a lot of research on what is called, for instance, intelligent reflecting surfaces. So how we can place in the environment either what are called the smart skins or special coating for buildings, for other urban infrastructure of these IRS.
Renato, I'm sorry to interrupt you. Maybe
Yes.
You stopped sharing your presentation. We can see that now.
Let me see. I didn't touch anything, so let's see. Okay, share. Okay. Should be back now. Okay. So as I said, moving with more and more innovation on the antenna side. From, let me say, relatively standard large antenna arrays to distribute electromagnetic intelligence in the environment. And of course, we cannot neglect the intelligence in every aspect.
I'm sorry, we still can't see your presentation.
It's strange because I see here that I'm sharing. Sorry for that.
Don't worry, we have time.
It's, after 2 years of this, we should be used.
Exactly. But every platform is different.
Okay.
We can see your screen, but it's black.
That's quite strange. Okay, let me say, I will go on. If you cannot see the screen, I wanted with this.
Now we can see that. We can see that again.
Okay, perfect. So you see how many challenges we have in order to improve the network and make this possible without these sometimes problems or the bottlenecks. We need also intelligence. We need artificial intelligence, machine learning algorithms in order to improve how we can deliver all of these. For us, this is just an example on how we can use AI in order to improve the quality of the network, how the network can reconfigure itself automatically without manual intervention. Not only in terms of reconfiguring itself for better managing the radio resources, but also for the maintenance. Overall, this was just an example, but of course, embedded AI, it is also a very important topic in this university challenge, as well the model-based software development. Last but not least is that we need to do that in a green way. So that means we cannot just grow the traffic, the capacity that we are using for the connections, for enabling all those new services, but we have to do that in a much more efficient way from energy consumption, power consumption point of view. So if we can grow the traffic 100 times. Not only this is a very big challenge, we have to reduce the cost accordingly, but we have also to reduce the power consumption. So as you see, how many watts per bit actually is the quantity that we have to reduce. So even if we increase capacity 100 times, we have to be able to keep the same power consumption that we have today. So we cannot make it grow. So we have to invent ways, and this is also part of our university challenge. So how to design power supplies that are and systems that are more and more efficient from this point of view. So as you've seen, this is the last slide. Even only if I'm touching, as an example, the wireless trends that we see up to 2030, we have a lot of hints and potential inspiration for the research that we have to carry out in the next 10 years. From artificial intelligence, embedded artificial intelligence in our networks, in our systems, efficiency of how we can deliver power to our systems. So as we see in these slides, from the antennas, from the also the circuits, so the semiconductors, especially the analog integrated circuits that we need to deal with the very, very high frequencies that are necessary to transmit and deliver the very high capacity. And then, of course, we have also an wish you the best in this challenge and see you in a couple of hours.
Renato, for your speech, and we are almost ready to welcome all the participants on stage. If you want, you can just close your camera and microphone, and you'll be anyway have the privilege to jump on stage later on for the jury moment. So let me share slide. I would like to. I made a mistake actually. I have to admit it because I put the wrong prices. Of course, you know the prices because they are on the website and on the guidelines you received. So these are the prizes, and we can't wait to send the prize to you. And about that, I would also tell you to all the guests that are here that our participants actually received a nice pack of gadgets yesterday or the last days. So if you received that, I strongly invite you to wear the t-shirts or some gadget you received from Huawei, because it's like to be all together in the same place. So let me just show you how this pitch session will work. You already know, but we would like to remind that every project team leader that will pitch today will have 5 minutes, and there will be also the time countdown on your screen. So be careful because we have a lot of projects to present. So it's important to respect the 5 minutes rule. After every pitch, we will invite the jury of the specific area of interest of the pitch for a short Q&A, 2 minutes Q&A. So every time I'm going to welcome the jury of the topic on stage. So don't worry, I will recall you, and you will have just to open your camera and microphone, and you will be on stage to ask questions to our team leaders and project leaders. So it's time to start. So let me just close my screen and welcome to the very first speaker. I don't know if he's the luckiest one or or not, but we will start with the topic embedded AI, and I would like to welcome Vincenzo Dentamaro.
Hello, can you hear me?
Vincenzo, yes.
Good morning.
Slide. You can share your slides.
I'm sharing the screen if you can. Can you see the screen? Okay, so let me know if I can start.
You have 5 minutes from now. So good luck.
Okay, thank you. Welcome everybody. I'm Vincenzo Dentamaro, PhD student in pattern recognition at University of Bari, and this is my presentation for the Huawei Italy University Challenge. So my presentation is named AI for COVID cough. So we all know that COVID is spreading, but what about a pre-screening technique capable of finding the presence of COVID only from cough and breath sounds by using a normal smartphone? So that's it. We invented in my team with the auditory cortex ResNet, also called OCO-ResNet, which is a biological inspired deep neural network, especially designed for sound classification. OCO-ResNet has demonstrated to provide state-of-the-art results on various COVID cough and breath classification tasks. And in addition, its generalization powers is also demonstrated in cross-dataset tests, both on COVID cough and breath sounds, which means that it has been trained on a dataset called COSVARA from India and tested on another dataset made by University of Cambridge, UK, and the network has proved to be robust to biases. The whole architecture is a neural network that is trained end-to-end and is implementable within smartphones using solely convolution and linear algebra operations. This is the neural network. It's built on the intuition that mammals have evolved the sound perception in order to focus on certain frequencies better than others, especially frequencies not audible to the human ear, even with a phonendoscope. That's it. And this intuition is encoded by the presence of three kinds of attention mechanisms: the squeeze and excitation mechanism, the convolutional block attention module, and another novel that I invented, which is called the sinusoidal learnable attention. This last attention mechanism, which means the big GUI here, acts like a hypothetical biological grandmother neuron by merging relevant information from activation maps at various stages of the network, acting like a biological pyramidal-like neuronal cell that have been reported to code for high-level concept.